Welcome to my presentation for CoDe2120. Data on floor tiles was scraped from the Alibaba website, where data such as name, width, length, unit, and material and cost were all taken. The data was then sent to an API in a Google spreadsheet, able to be used for the waste reduction processes in later steps. Data from the data input, including the footprint, floor-to-floor height, and the levels, were all taken and prepared for future steps. Then script was made to be able to test the shape of the building footprint, including rectangle, L-shape, T-shape, U-shape, and S-shape. Needed data from the API was taken using the HTTP request, allowing for me to input the glass material and allowing me to help reduce waste in the glass for the facade. The read.json component was used to gather data of an item for dimensions, width, height, and length, and also the unit. These were all put into an expression which converted any dimensions if they were needed into the direct dimension that we were using, and also added an extra dimension for mullion consideration. The volume mass of the building was taken, and the outer surfaces to be used for the facade were taken as they were the only necessary surfaces needed for the generation of a facade. A similar process has been done for the top and bottom, allowing for the vertices to be joined into lines, allowing for the edges to then be used for later calculations. The footprint of the building was taken, and the correct shape was found by the script. This was done through the zeros and ones, which stand for a closed corner or an open corner. A quick ladybug sunlight analysis was also done, and this was to find how the sun reacts within the Sydney area. This would allow me to consider where the canopy lengths on each of the windows has to be longer and where it can afford to be shorter. Level curves were taken, exploded, and shifted for a later step. From where the data was imported from the HTTP request, there was a list which was reversed and one which was not reversed. In this case, for the side with the reversed list, the points in the previous step were used in creating the window lines by dividing the main length of each of the level lines. The window width is based on the points being divided within the correct width of the lines, also considering the mullion. The points were moved to a height which allowed for the creation of window height lines. The length and the height were then taken, and the length was then subtracted by the full dimension length of a window to find how much waste is used per window, and the data is then recorded with its index for each loop. Through the use of a reversed and non-reversed side, this allows for 2 rotations of the window to be considered in the waste reduction process. On the second half of the script, I decided to save the data from the panels after all the looping has been done, just to stop the need for looping all the way over again every single time that the data is accessed. This second part of the script that we're accessing now can be disabled while the first half is running to save calculating time in earlier parts. Both sides are considered, and only the side with the least waste is not culled and is able to move on to later steps. Amount of waste, index, and direction is then taken and outputted to the next step. The index is then used in the same process as shown before with the HTTP request, and is used to call for the one with the least waste. Another cull pattern is used to make sure that the data can only access the side that it is actually necessary towards. So in this case, the data has been culled as there is no D2 in the D2 checker, and therefore it's been culled, and there is no direction 2 as it is unnecessary. A plane in the location of the first floor's canopy is used to only allow the canopy area lines to be taken for the first floor. Depending on their relation to the cardinal direction northeast, south, or west, they were moved away from the building by a certain amount to help create surfaces. These surfaces were extruded and also moved upwards in a series to allow for each of the floor's canopies to be considered for. The amount of material when creating the canopy was found. Waste is not really calculated in this part as the material for many canopies on many different buildings can differ, so accounting for that many materials wouldn't really make sense in this case. Especially since in the building process many canopies can just be created there by the builder, and inevitably waste is generated by these processes. The required information was then pushed to the Google Drive and is able to be taken into any script by using the data input component. If at any other point a different window wants to be chosen for design reasons, such as the window being too small, in this case another window can be chosen through the list item component after the sort list, which is sorted between least waste to most waste. As seen below, waste is still fairly minimal, as it is only 0.0248 of a meter. Data for both directions, direction 1 and direction 2, are inputted into the final components, as only one will have data actually going into it, since one of the sides was disabled fairly many steps ago. The script even responds to cardinal directions and covers sides which need to be covered, doesn't bother making sides where they are not needed, and this allows for saving of material when creating the canopies. The script is able to work for all of the required footprints. U as already shown, T, L, S, and rectangle all work and can be identified by the script. Through testing, it has also been found that the script is also flexible enough to work with any given footprint. Thank you for listening to my presentation.